Hello everyone, welcome to our channel. In this video, we are going to talk about reinforced concrete. We are going to discuss about design of slab, beam, column, and foundation. What is slab? Slab are horizontal flat elements forming floor and roof in buildings and normally carry lateral action. It can be of solid uniform thickness or with ribs running in one or two directions. Slabs are classified according to the method of support as follows. One-way solid slab. It has uniform thickness, bending, and reinforced in one direction. It is only suitable for short spans. Two-way solid slab. It has uniform thickness, bending, and reinforced in two directions. It is economical for medium spans with medium to heavy load. Rib slabs. It is cast integrally with a series of closely spaced joints, which in turn are supported by a set of beams. Rib slabs are designed as a set of parallel T-beams and economical for medium spans with light to medium live load. Waffle slab. Two-way slabs reinforced by ribs in two directions. It is able to carry heavier loads and span longer than rib slab. Flat slab. It has uniform thickness, bending, and reinforced in two directions and supported directly by column without beam. Flat slabs without drop panel. Flat slabs thicken at its column support with column capitals or drop panels to increase its shear strength and moment resisting capacity. It is suitable for heavily loaded span.
What is beam? A beam is a structural element that primarily resists loads applied laterally to the beam's axis. Its mode of deflection is primarily by bending. The loads applied to the beam result in reaction force at the beam support points. The total effect of all the force acting on the beam is to produce shear force and bending moments within the beam that in turn induce internal stresses, strains, and deflections of the beam. Beams are characterized by their manner of support, profile, shape of cross-section, equilibrium condition, and their material. Beams are traditionally description of building or civil engineering structural elements, but any structure such as automobile frames, aircraft components, machine frames, and other mechanical or structural systems contain beam structures that are designed to carry lateral loads are analyzed in a similar fashion. Type of beam: simply supported beam, fixed beam, cantilever beam, continuously supported beam. Simply supported beam. If the ends of a beam are made to rest freely on support beam, it is called a simple, freely supported beam. Fixed beam. If a beam is fixed at both ends, it is free called fixed beam. Its another name is a built-in beam. Cantilever beam. If a beam is fixed at one end while the other end is free, it is called cantilever beam. Continuously supported beam. If more than two supports are provided to the beam, it is called continuously supported beam.
A reinforced concrete column is a structural member designed to carry compressive load, composed of concrete with an embedded steel frame to provide reinforcement. For design purposes, the columns are spread into two categories. Show the rectangular tie and round spiral concrete column. Tie column have horizontal tie to enclose and hold in place longitudinal bars. Tie are commonly number 3 or number 4 steel bar. Tie spacing should be calculated with ACI code. Spiral columns have reinforced longitudinal bars that are enclosed by continuous steel spiral. The spiral is made up of either large diameter steel wire or steel rod and formed in the shape of helix. The spiral columns are slightly stronger than tie columns. The columns are also categorized into three types by the applied load types. The column with small eccentricity, the column with large eccentricity also called eccentric columns, and biaxial bending column.
Foundation is the part of structure which transmits the loads from the structure to the underlying soil or rock. It is usually placed below the surface of the ground. All soils compress noticeably when loaded and cause the supported structure to settle. The two essential requirements in the design of foundations are: first, the total settlement of the structures shall be limited to a tolerably small amount, and number two, the differential settlement of various parts of the structure shall be eliminated. There are six types of foundation. First, pad footings. Pad footings are used to support and transmit the loads from piers and columns. Pad footings tend to be the simplest and the cheapest foundation type and are used when the soil is relatively strong or when the column loads are relatively light. Alright, number two, combined footings. Where two columns are close together, it is sometimes necessary or convenient to combine the footing to form a continuous base. If possible, the base is arranged so that its center line coincides with the center of gravity of the loads, as this will provide a uniform pressure on the soil. Alright, number three, strap footings. Strap footings, as shown in the figure 1.2c, are used where the base for the interior column must not project beyond the property line. A strap beam is constructed between the interior footing and the adjacent interior footing. Alright, number four, strip footing. Strip footing are commonly used for the foundations to load-bearing wall. They are also used when the pad footings for a number of columns are in line or so closely spaced. Number 5. Rough foundation. A rough foundation is a combined footing which covers the entire building and supports all the walls and columns. This method is particularly useful where the column loads are heavy or the bearing capacity is low, resulting in the need for the large bases. Number 6. Pile foundation. When a solid bearing stratum, such as a rock, is deeper than 3 meters below the base level of the structure, a foundation supported on the bearing piles will provide an economical solution. The pile loads are either transmitted to a stiff bearing layer, some distance below the surface, or are transmitted to the soil by the friction along the length of the pile. Figure 1.2f.